Hi, I'm Jason. I'm one of the senior MongoDBAs at ObjectRocket by Rackspace. During this session, I'm going to talk about chunk distribution, data distribution, and a sharded MongoDB cluster. MongoDB often does a good job at distributing this data, but sometimes manual intervention is needed. A little bit about me. I started on relational databases in public education, then moved to financial services. Next, I did online media distribution, combined with a paywall. I started looking into analytics, started working with columnar databases and engines with compression. At ObjectRocket, I made the switch to NoSQL, and now support customers large and small. Each position had its different set of challenges. Working with the EDU, you had a lot of different customers, a lot of different workloads, and customers with all sorts of different knowledge bases. Working in financial services, I was dealing a lot with OLAP, long-running queries, long-running jobs, not so much OLTP. When I moved to the media distribution, it was all B2B combined with a paywall. That means, for the most part, the workload was the same day after day except for breaking news. And then, like I mentioned before, working with ObjectRocket, every day is different. Customers large and small, could be anywhere from 5 gigs to a terabyte, depending on the customer. So during this presentation, I'm going to discuss MongoDB and sharding. What is a chunk in MongoDB? Chunk distribution and scaling MongoDB. Use cases for splitting those chunks. Use cases for merging chunks. And possibly reconsidering your shard key. I'm going to be focusing on versions 2.4 through 3.0, and 3.0 including WireTiger. Chunk distribution is abstracted from the storage engine, but depending on the storage engine you're running, it can influence chunk migrations. Merging chunks requires version 2.6 or greater. It wasn't introduced until that version. In 2.4, there is no admin command to merge chunks. Feel free to ask questions as we go, or you can save them until the end. So MongoDB is a document store. MongoDB stores its documents in BSON format. BSON was created to improve performance and allow for additional types and improve the integrity of the data. For example, you don't have to worry about validating dates on the application side, and BSON also allows you to store arrays, whether you want to store documents in those arrays or just numbers or strings. This is important. One thing I want to note, it's important, you can see in the example document that I used short field names. In a document store, the field names are stored on every document. That means the duplication of data, and that's going to influence your data size. For example, N will map to name, A for age, H for height. And data size is going to impact all of your resources. We're talking caching, indexing, compression, uncompressing data off disk, and also CPU usage, both for memory mapped and WireTiger. Here you have a MongoDB sharded cluster. At the top, you have a MongoS tier, which is responsible for connection handling, query routing, result merging, and cluster changes. On the left, you have the config tier, which is standalone MongoDBs in version 3.2 and less. In version 3.2, it can be a replica set running WireTiger. What this does is it holds the configuration metadata for your sharded cluster. The config servers are maintained by the MongoS and the MongoD layer. Both layers do make changes to this configuration data. At the bottom, you have your replica sets. These are the MongoD nodes that are holding your data in your indexes and running threads like Chunk Manager, the TTL thread, and Range Deleter, which help keep your data in check and also maintain make sure that you're getting the right results back when you're running your read operations. So what is a chunk? Chunks are documents stored in the config chunks collection on the metadata server. MongoDB defaults to 64 megabytes, and and every collection that you shard will always have a min chunk and a max chunk. These min chunks and max chunks are defined by a special type called min key and max key. In this example, you see your namespace. You also see last mod epoch. Last mod epoch will relay back to the config.collections collection, and that can make sure that your chunks and your collections are in sync. If that value strays from your collection information, or your collection, the document in the collection, the MongoOS will fail to load the chunk map and it'll consider the collection unsharded. Documents in this chunk range are greater than or equal to the min key there, and documents will be less than the max key. The shard value references a shard in your sharded cluster and must be present in the config.shards collection. If that shard is not present, if that document is not present in the shards collection, again, the MongoOS will fail to start, and that MongoOS will be not operational. I mentioned the chunk manager on the previous slide. A chunk manager is an actual process that lives on the MongoDB, and what that does is it is aware, it caches a copy of the chunk map and is aware of all the chunks that it's responsible for. So if a read operation comes in and that shard has data that it does not have in its cache, it will not return that data. This is important because if you have a move chunk operation in progress or orphan documents, you don't want that shard returning duplicate data or data that's been deleted in the past. Next, I'm going to discuss 3 use cases that require manual intervention for splits. The first use case is unbalanced operations, and in this case, we're going to focus on writes. What you see here is shard 1 is receiving 80% of what we're going to say update statements, and shard 2 is only receiving 20%. You're most likely going to see this in MongoStat or MMS or some other monitoring utility that may be monitoring your shard. It may be monitoring your database at the replica set level. This is important because the shard that's receiving 80% of your writes is going to have higher lock intention, higher resource utilization, and it's likely going to cause a latency in your reads and writes that are directed at that shard. How you start to resolve this, how you start to troubleshoot this, is MongoStat or MMS has given you the database that is being highly utilized, and you're going to go to that shard, increase the profiler size and the profiler level so you're capturing all operations for an extended period of time. With that profiler and op log data, if you choose to also aggregate the op log, you can use the aggregation pipeline to identify what we're going to call hot documents. And here's a profile example using the aggregation pipeline. You have a match phase because you're targeting the writes to that shard based on your MMS and your MongoStat stats. You know your namespace because you've done a few pre-aggregations to identify the collection. You're going to group on the query portion of the update statement. In this use case, the shard key is UUID, and that's causing that increased activity to that particular shard. We're going to count them, and then we're going to just count and then sort descending, and then limit 5 to see who the top 5 offenders are. It's possible you have more than 5, but we're going to focus on the first 5. The reason for identifying the top 5 is because the goal here is to move these most active users off this shard onto other shards. You don't want to move all the offenders off. You may want to leave some just because you don't want to leave the shard not doing anything anymore, but you want to balance your resources as best as possible. So what you see here is even though the UUID generator is random, it's still allowed for two UIDs of really active users to reside in the same chunk. And in this case, they're actually adjacent. And this is a real scenario that we've seen before and identified and rectified using this exact case. Now that you've identified the documents, you can use MongoDB's split helper to split the active users out of this chunk and get them to different shards. The reason you're going to do 3 splits here is because you want to isolate those 2 users. So the first split will separate the 3 bottom documents from this chunk, and then the 2 remaining splits will allow you to isolate those 2 documents. Once you move these documents off of these shards, you should see lock intention, and if there's any queuing, that should decrease as well. So we talked about moving chunks. Here's how you would actually move a chunk manually. The balancer will do this for you if you do enough splits to where you meet the threshold for the balancer to start moving chunks. But if you're only doing a few splits, you're most likely going to want to move these manual. Also, you're going to want to put them in your least active shards. You have your namespace. You have the bounds for the chunk that you want to move. In this case, if we were isolating them to single documents, so your range may only be 1 document, and then you're going to provide your destination shard and then the secondary throttle. The secondary throttle is important because it tells MongoDB to make sure the documents are replicated on the destination shard before completing the chunk move. How a chunk move functions. The source shard will contact the destination shard to initiate the chunk move. The source shard, the destination shard will accept the chunk if there's no other activity no other metadata changes going on that shard at that time. Next, the indexes will be built, and then the destination shard will start requesting documents from the donor shard. And in this case, that's the cloning section when you see in the logs. After the final document's processed, any changes that were occurring during this chunk move are then applied to the destination shard. Once those changes are applied, the destination shard will contact the config database and update the configuration metadata. Once the metadata has been updated and there are no more open cursors to the donor shard, range deleter will kick in and begin deleting this chunk from the source shard. Range deleter is a queuing system. The range is appended to the range deleter queue, which runs on the MongoD, and it would then just clean up using delete statements all the documents that have moved to the destination shard. Earlier I mentioned orphan documents. For example, if you had an election while range deleter is processing its queue, it will actually leave, a partial chunk behind because that process only lives in the primary. And when a new secondary is elected, it knows nothing about what was in that range deleter queue, whether it was only 1 range or multiple ranges that were waiting to be processed. Another word of caution with 2.6 and greater, MongoDB made it default that it's going to archive all moved chunks. That means if you moved 100 gigabytes of data, 100 gigabytes of BSON is going to be written to disk. Well, probably a little bit less because it'll be there won't be indexes, but that data will be written to disk in a special folder in case something went wrong with the chunk migration. Feel free to turn this off if you do not have the storage to handle both incoming data and archiving of moved chunk data. So the next use case is unbalanced resources. This is a common cause of JumboChunks. What a JumboChunk is a chunk that exceeds the size set in your configuration, and it can either be by size or document. In this case, we're looking We're looking at one by size. So you can see on shard 1, you have JumboChunks that could be anywhere from 65 megabytes into the tens of gigs, depending on how long the JumboChunk's been around. During a balancing round, MongoDB will try to split these, but if it can't, they'll just remain until you have to intervene. Again, this will affect your system resources, your CPU, your memory usage, your disk I/O, and your cache, and including balancing. It'll cause your balancing process to take longer because it's going to fail on these JumboChunks. And then especially with Wired Tiger and even Memory Map, shard 1 is responsible for a lot more data than shard 2. Again, the requirements for a JumboChunk are chunks that are larger than the chunk size or contain more than 250,000 documents. That is hard-coded and you cannot change that. If you have a chunk that is larger by document, you're not going to be able to move that chunk, and you'll have to rectify that in another way other than splitting. The MongoOS is what keeps track of bytes coming in, and when it sees enough bytes for a particular chunk, it will attempt to split that chunk by issuing a command against the MongoD to see how big that chunk is. So identifying JumboChunks or existing JumboChunks, you can sh status true, which increases the verbosity, will actually show you if the balancer or the MongoOS has flagged a chunk as a jumbo. But that's not always the case. If it's never tried to move that chunk, it would never be flagged as a jumbo. If you tried draining a shard using move chunk, if you're trying to shift resources or move hardware, move chunk will actually report an error that the move chunk failed due to the chunk size. Or while you're doing your investigation with count or the aggregation pipeline, 1, if it's by document, or 2, you can incorporate average object size. So if your average object size is large enough and so is your count, you're obviously going to exceed the chunk size. Also, Object Rocket has a utility on GitHub, chunkhunter.py. It's a utility that will go out there and report the size for all your chunks. It will do it for an entire namespace or just a particular shard. Multiple people from Object Rocket have contributed to this, including myself, and also people like David Murphy from Percona. So causes for JumboChunks could be importing of data. If you're doing a Mongo restore or a Mongo import, the MongoOS and the MongoD just can't cope with all the data coming in, and the chunk will exceed max chunk size and will remain a jumbo. At the same time, if you're doing a lot of ingestion, there might be multiple config metadata locks going on. If one MongoOS has a lock and another MongoOS is trying to do a split, it's not going to get that lock, and the chunk may grow beyond that size before it gets a chance to try splitting it again. Another scenario is compound shard keys. It's common that when the MongoOS goes to split existing data using 2 or more fields, that it may not get the splits right, and you may be left with a lot of jumbo chunks. See it most common when you append ISO date field to increase cardinality, or when you have compound keys that are 3 or more fields. Rectifying this issue, you can use split at and split find, like I mentioned before. That's if you're only doing a few splits. In some cases, sharding existing data may only produce a couple. Question?
Yeah. So, and maybe you said this already, but how do you find the documents you need to, where you need to use the split out or split find? How do you know that they're hot?
How did I know they're hot?
Yeah.
Let's see. So in this aggregation here, you're looking at your profile data. With a profile level of 2, it's going to record all operations. And what I'm doing for this particular update statement is I'm grouping by the query portion of the update statement. So I know all the updates are coming in for that UUID, And then when I'm doing the descending, you can see in this case, 28,000 updates in 60 seconds were for a single UUID.
Okay.
And it'd be different if, I guess I didn't have enough room, but if I listed all the results, in this use case, the top 4, where it went like 28,000, 25,000, then it drastically dropped to like 2,000, 1,000, or 500. So you know that these were very busy. And we had a collection of users that just happened to be inside this one chunk that created this hotspot.
Okay, thank you.
You're welcome. And you can also look at your op log too. In this case, I use the system.profile, but your op log will also have all you'll be able to aggregate on that, and that'll also have all your write statements. Just a word of caution, you may want to dump the op log or the system profile to another testing database, so you're not running aggregations on your production shards, because you are going to affect your cache. Another way to solve a lot of splits is, again, use our Object Rocket utility, Chunk Manager PY, which I'm going to explain in the next slide, or data reduction, which I mentioned when your documents exceed the 250K. That's the only way to resolve that, unless you just leave that chunk on that shard indefinitely, and don't try to move it ever. And then last is resharding the collection. Some of these cases and workarounds or solutions may only be short term and may be able to buy you time until you're able to reshard your collection to solve the actual problem. But if you just have a few jumbo chunks or a few empty chunks now and then, it's just part of standard maintenance. Here's another aggregation example where you may just want to use average object size, use the aggregation pipeline to see how big a chunk may be, or not, yes, how big, how many, if you're going to run into a case where a jumbo, if UUID is coming up a lot inside the same chunk, combined with average object size, you may have an issue where cardinality for that shard key was not high enough, and it's going to result in a jumbo chunk. I spoke of the data size command earlier. What the data size command is, it's a MongoDB command that will measure the chunk range for you, so you don't have to do these aggregation and count operations or the math yourself. What you do is you pass the namespace to it, the key pattern, and then the min and the max. It doesn't necessarily have to be a chunk. It could be any min and max you want, as long as the range exists. But in this case, we care about the chunk size that we're trying to measure. The not shown here, the data size command does have an estimate Boolean field. And that's very important because what this command will do in its current state will actually page all this data from disk. And if you have a jumbo chunk that's 3 gigs, it's going to page 3 gigs. And if you're running WireTiger, it's going to have to uncompress that and read that into RAM. So I would recommend passing the estimate flag, which is also what the balancer does when it's trying to move chunks. When passing estimates, a very light command. But if you need actual hard numbers, you can run the data size command without it. Just make sure you have the appropriate resources. And at the bottom is the flow of one of our 3 utilities. Chunk Manager is a wrapper for Chunk Hunter and Chunk Splitter. In this use case, when I was talking about importing data, and you had a lot of splits to do. For an example, we had a customer that sharded an ID hash, and he had 500 chunks that needed to be split, but they were all going to require multiple splits. There's no way you can do 1,000 splits by hand. So what this utility does is it'll go out, it'll measure the chunks using the data size command. It will then store that data in a temporary collection in any namespace that you choose, Chunk splitter is then run. It'll read that collection that chunk hunter created and go out and split those chunks for you. Chunk manager will then recall chunk hunter to see if it has to do any more splits, and that's the benefit of using this utility, is it'll do the recursion for you. You don't need to keep running each manually. You will want to monitor the process. Chunk hunter by default does use estimate, so it should be a light operation, but you are modifying your configuration metadata. After a process like this, when we're talking about splits and merging, it's always good to maybe start another MongoOS or bounce one of your existing MongoOSs if it's not going to impact your application. What that does is it causes that MongoOS to reread the chunk map and make sure everything is valid, and that none of the splits that you've done or any of the utilities have caused an issue with your chunk map in any way. And one note about the utility, if chunk splitter runs and the number of JumboChunks matches the previous run, it will stop and say you need to intervene and investigate your data because it can't split that for some reason. And it may just be a chunk that's jumbo by document. Another use case for manual splits or pre-splitting is new collections and or small collections. MongoStat will show you a busy shard. You have one shard that's maybe getting 1,000 reads per second and other shards that are getting practically none. Or for new collections, you could utilize num-initial chunks. What num-initial chunks does is it creates a defined number of chunks when you initially shard, and then these chunks can be distributed among the cluster to scale out the incoming reads and writes as new data is added. That's only for hash shard keys, by the way. For non-hash shard keys, you could, if your shard key is random, you could import test data and then remove that test data. What that will do is it will create chunks for you. You can then distribute those empty chunks that match the data that you're going to be inserting in the near future. And the small collections may require manual splits. If you only have, say, a few hundred megabyte of data, and you're not going to create many chunks, but you say have 10 shards, what you can do is you can create smaller chunks, so you can distribute those among all 10 shards. Even though they're going to be smaller, you still are going to be distributing these thousands of operations across all your shards and not wasting resources. So considerations, like I said before, you want to consider your workload. And if you know you're going to be write heavy, you're going to want to get as many chunks and distribute that initial workload as much as possible. And can your shard key do this? If it can't, you may want to reconsider your shard key choice if it's an important part of this workload. Let's see. And there's an example command using num-initial chunks. In this case, I just passed that number 1024, and what that will do is it will create that many chunks, and if I had 10 shards, it will split that up as evenly as possible across those 10 shards. Knowing the current collection size or the expected collection size is very important, because as you can see here, to calculate that value, we want to pass the expected collection size in megabytes, divide that by your chunk size, and then times it by 2. I don't know if you've ever noticed, but when you initially shard a collection with existing data, it's going to have, MongoDB tries to create 32 megabyte chunks. That gives room for growth, but is not too small, and that's what we're trying to achieve with that calculation. Another note, the balancer must be off when you're doing num-initial chunks, because if the balancer is on and not moving chunks, well, actually, regardless, if it's on and you do num-initial chunks and you have enough chunks, the balancer may see that and start moving one of the chunks, and if that's the case, everything will stack up on that first shard and they won't be distributed. If the balancer is moving a different chunk for a different namespace at the time, same thing will happen. Now I'm going to talk about merging. What what you see here is another use case for unbalanced operations. Shard 1 and shard 2, or you could have many shards, but in this case I'm using 2 shards. Again, the first shard's getting the majority of the operations, and then you go look at the storage, and in this case we're not dealing with JumboChunks, we're actually dealing with empty chunks. Shard 1 has a lot more data because the chunks actually have data and documents in them, where shard 2, the chunks exist, the chunks are balanced across all your shards, but they're empty, no documents, no data. And like before, this is going to affect your CPU, your RAM, disk, and your WireTiger cache. And this is also a little bit more important when it comes to the WireTiger cache as well, because WireTiger is a little bit more RAM sensitive. And if one of your shards has a lot more data and it's paging more out of off of disk and into RAM, you might see performance issues with one shard and not the other. Memory map can cope with this a little bit better. You just may see increased latency in some of your operations. The most common cause for this is just inserts with natural splits over time, but then a business requirement where the workload changes and removes have been introduced to the workload. And what you see here is, 3 out of the 4 shards didn't have any or had very few removes, but you can see shard 2, a lot of data was removed from that shard. Again, the chunks are balanced, and MongoDB's balancer doesn't care about how many documents or the size of those chunks per shard. It just wants to make sure that all the chunks are evenly distributed. Ideally, you want to keep your shards uniform because this is going to be a waste of resources. Whether this is virtual or physical hardware, you're going to, at one point, you provisioned enough storage and resources to handle just as much as shard 4. So shard 2 is really wasting resources and money. Periodic maintenance and review over time can prevent this kind of wasted resources. So the merging process. So how we resolved this in the past using this merging process, only one chunk move can happen at a time. So you first check the balancer state. If the balancer is not running, then we could go ahead with this process. Because we had existing tooling in place, we utilized Chunk Hunter and read the results in from that collection. Merge chunk requires that the empty chunk be merged with the adjacent chunk. Therefore, they have to live on the same shard. If the empty chunk and the adjacent chunk reside in the same shard, you can merge them in one operation. Else, you're going to have to move the empty chunk to the shard that's holding the adjacent chunk and then merge. The reason you want to move the empty chunk is because it's a lot less work to move no documents than it is to move the chunk that's holding data. What did we learn from this? The reason we used JavaScript in previous tooling was because we thought this was going to be a rare occurrence. But over time, we're finding more and more people that come on our platform or have changed their workloads over time have been running into this problem. Also, relying on Chunk Hunter wasn't an efficient way to handle this. Running Chunk Hunter and then running the merge process, in that fashion, it just wasn't efficient. It was taking too much time. So the idea behind this is to actually create another Python tool, like we did with the other utilities, and then utilize the config.chunks collection to improve the process. Also, not try to schedule this around a balancer state or balancer window. Instead, just check if the balancer is running, sleep. If not, if it is running, just wait until it's not, and then continue on with the process. Another use case, which is more severe, is the introduction of a TTL. TTL is a special single field index that will delete data over time, based on the threshold that you pass to expire after seconds. Can be greater than or equal to 0, depending on how you want to set the field. In this case, the data was evenly distributed, The shard key was perfect for the workload, and they wanted to retain all data. Over time, 1, the workload changed, 2, the TTL was added, and then 3, a balancer window was set, which just compounded the problem. The data started building on shard 4, and because the balancer could not move data off until the balancer window was, until it was in the balancer window, data would just keep building on shard 3 and 4, and then once the balancer window kicked in, you would see the data then migrate to the other shards. Because of the other shards had older data, the TTL would be constantly creating empty chunks on those shards, but leaving the most active data on shard 3 and 4. And this is not okay. This indicates that there's a problem with the shard key now because the workload has changed over time. So merging in this case was a short-term solution until the collection could be resharded. Chunk size and split. So chunk size is a global change. There's no way to specify it based on a namespace. And I'll discuss shortly how you could possibly get around that. Split vector. Split and split vector are going to be logged. So this will tell you how often you're running splits or how often MongoDB is evaluating a chunk to be split. I don't have a use case for decreasing the size of a chunk. We find that the 64 megabyte is good for most use cases, but we've had cases where we do want to increase it, and one being session data. Session data should really be stored on a key value store, Redis, Memcache, anything very low latency, very lightweight. But in some cases, some applications, some developers still choose to put session data in MongoDB. And in this case, combined with the TTL, you want to increase the chunk size. And what this will do is it will prevent a lot of splits. And combined with the TTL will keep the data in check, and it'll just keep rotating or churning the data for you without having to split anymore. And like I said before, with the merging, it would be good to reevaluate your shard key. How frequently is this occurring? Is it often enough that it's either paging you, or costing you disk or personnel hours, or is it causing you unplanned maintenances like step downs or unplanned elections? And if so, it's time for you to review your workload. You're going to want to review your schema and reprofile your data. As mentioned before, increasing the profiler to capture all operations, and then see if a better shard key can be chosen or created. A lot of times, the best solution is creating a new shard key combined with hashing or combining it with existing fields that were already on your structure, on your schema. And then the next question is, can you reshard? Depending on the size of your collection, how do you approach that? Can you dump and restore? Can you do dual writes? Can you drain all the data into one shard and then restart the server, the cluster with that collection unsharded? There's ways to approach it. You just have to find what's best for you and your company and your application. Object tracked by Rackspace. We can help you overcome all of these challenges. We do 24/7 support for MongoDB, Redis, and Elasticsearch with Kibana. Any questions? Nope. Thank you.